Welcome back. Nice to see you. So students, we have been discussing the chapter circular motion. Now, let us start with the next module of the chapter circular motion. In this module, yes, we are going to discuss the concept of angular velocity and angular speed. Now students, in 11th standard you have studied linear velocity and linear speed, yes or no, translatory motion. Similarly, in circular motion, we are going to study angular velocity and angular speed. So, are you ready? Can I start the module? Alright. First students, we are going to define what is angular velocity. Now students, keep this in your mind. Linear velocity, there are two types. Average linear velocity and instantaneous linear velocity. Similarly, angular velocity also there are two types. Average angular velocity and instantaneous angular velocity. First, we are going to see what is average angular velocity. Is that clear? For that, I am going to consider a particle. Now this particle is performing a circular motion. Alright. Let point O be the center of the circular path traced by the particle. Now, the particle is at position A. So now OA will be the radius vector. Is that clear? OA is my radius vector. Now let us say that this particle starts to move. Now this particle moves from position A to position B in time t1. Alright, in time t1. Then now OB will become my radius vector, and as you see here, the radius vector has traced some angle. What angle? Yes, the radius vector has traced an angle θ1 in time t1. Is that clear? Fine. Now, again the particle is moving from position B to position C. Now hold on. This cloud is very important. The particle is moving from A to C in time t2. So from A to C, it has taken time t2. Is that clear? T2 is not the time from B to C. T2 is the time from A to C. Now, OC will be my radius vector. Now with respect to A, the radius vector has traced an angle θ2. With respect to A, the radius vector has traced an angle θ2 in time t2. θ1 was in time t1, θ2 was in time t2. Alright, now we can define what is average angular velocity. Now what is average angular velocity? The average angular velocity is defined as the time rate of change of angular displacement. This is your average angular velocity. The formula is omega average is θ2 minus θ1 upon t2 minus t1. Alright, θ2 is final angular displacement, θ1 is initial angular displacement, t2 is final time, t1 is initial time. Is this clear to you? So this is your average angular velocity, similar like average linear velocity. Is that clear? Fine. Now the next one we have is instantaneous angular velocity. For that, again, I am considering a particle. This particle is performing a circular motion. O is the center of the circular path traced by the particle. This particle, alright, is at position A. Now OA will be my radius vector. Now, this particle is moving from position A, alright, to position B in a very, very small interval of time. What? In a very, very small interval of time, it is moving from position A to position B. Now what will happen? OB will become my radius vector. Since the time interval is very small, the length of the arc AB is also small, delta S, and the radius vector also sweeps a very small angle, and this angle is delta theta. And what is this delta theta called as? Yes, very good. Delta theta is called as instantaneous angular displacement. Yes or no? Fine. Now what is instantaneous angular velocity? Instantaneous angular velocity is nothing but, it is defined as the time rate of change of a limiting angular displacement. Limiting angular displacement means delta theta. The time interval is very, very small. Is that clear? And what is the formula for instantaneous angular velocity? Omega instantaneous is nothing but limit delta t tends to 0, delta theta upon delta t, which is equal to d theta upon dt. So instantaneous angular velocity comes when the time interval taken is very, very small. Alright, it tends to 0. It's very, very small. Is that clear? Now students, velocity, angular velocity. Alright, it is a vector quantity, and we know how to find out the direction. We saw for instantaneous angular displacement. Yes, which rule will you use? Yes, the direction of angular velocity is given by your right hand rule. Now, in the last module I gave you a shortcut. What is that? Yes students, very good. You're paying attention, that's nice. If the particle moves in the anti-clockwise direction, then instantaneous angular displacement will be pointing up and it is positive. Similarly, omega also will point up and it will be positive. And if the particle is moving in the clockwise direction, then instantaneous angular displacement will point down and it is negative. Similarly, omega also will point down and it is negative. Is that clear? Now, what is the SI unit? SI unit is radian per second. And what are the dimensions? Dimensions are m raised to 0, L raised to 0 and T raised to minus 1. Is that clear, students? Any doubt? Fine. Now we have to go to the concept of angular speed. Now what is angular speed? Very simple. Angular speed is a magnitude of angular velocity. And what is the formula? Omega is limit delta t tends to 0, delta theta upon delta t, which is d theta by dt. See here, I have not taken the vector. I have just taken only the magnitude. Is that clear? So keep this in mind. Angular speed is a scalar quantity. It is a magnitude of angular velocity. SI unit, of course, will be the same, radian per second. Dimensions also will be the same. It is m raised to 0, L raised to 0 and T raised to minus 1. Is that clear, students? So you have learned the concept of angular velocity and angular speed. Alright, I'll catch you up in the next module. Until then, you're all born to win. Keep working, rise and shine.
करता है यार